Welcome to another session of our series of tutorial in R for data science. And in this session, we are going to cover functions, and we'll introduce what functions are. We'll look at inbuilt functions and user-defined functions. So what are functions? Functions are self-contained blocks of code that perform specific tasks. So you call a function, then you give or you define the arguments, then it performs certain tasks. For example, the function mean. There's a function called mean. This is a statistical function, and the mean performs the arithmetic mean, that is the summation of a vector divided by the total number. For example, I want the mean of some numbers here. For example, the mean of 100, 300. Then I run this, and here it gives me it is 133.666. Now, so functions make work easier. For example, this function means what it does is that it takes this one plus 100 plus 300 divided by 3. So in normal way, could do this with the sum of these numbers, that is 100 300. It's the sum of that. So then what do? You divide by 3. See, that gives us the same answer or the same value. But using the mean is much easier than doing it. That's why it is a block of code. It's a block of code. It's all this. This is what mean is. It performs a certain task. There are several functions in R, and there are basically two types of functions: the inbuilt functions and the user-defined functions. In inbuilt functions, they are mathematical functions. For example, the unique, for example, the absolute value, or the ABS function. So there is the ABS function in mathematical functions. There is this function called ABS, which returns the absolute value of a certain number. For example, the absolute value of 95. It gives you it's 5. That's the absolute. As the absolute function. Another mathematical function is the square root function, SQRT. SQRT is another function. It gives you the square root of a certain number. For example, the square root of 9. That is the square root function. Another mathematical function is the exponential, exp, which gives you exponential value of a number. There is also the log functions. So basically, those are mathematical functions. There are also some statistical functions. For example, the mean. The mean is a statistical function. The mean. There's also the median. Is the median. Another statistical function is the correlation. That's COR, COR, and variance. There are also some data manipulation functions, and example is unique, which returns the unique value in a vector. There's also subset that subsets a data frame based on certain conditions. There's also aggregate, and there is order. There's also some file input or output functions. For example, the read .csv, which allows us to import or to read comma separated value. That's the CSV. There's also write.csv, which allows us to write data from R to comma separated values. There's also write.table. So those are some examples of inbuilt functions. and say there are some other functions, for example, in other functions, for example, in the there's the ggplot function in ggplot2, there's the select, there's the filter, there's the summarize, there's order by. Basically those are in the core tidyverse package. The second class, or the second type of functions, are the user-defined functions. This is whereby R provides or R allows us to write our own functions. And when you're writing your own functions, it's good that when writing your own function, it's good that your function should have a unique name. Then after having the unique name, you have to specify what that function does. You have to specify the arguments. You can also do commenting, or actually what your function does by using the hashtag, then what the function does. So this is the syntax of writing a function, whereby here I'm saying f, I'm creating a function called f, and I'm using the keyword function. So this is also a function. This is a function in R. So I'm using the function, and then I open the bracket. These are the arguments that I'll pass to that function. And then I open the curly braces, then what the function does. For example, I may have a function here, for example, function called f. Then I call the function. Then I may specify the argument. For example, this function of mine maybe is a simple adder. It adds some vectors or some arguments. So I specify this argument, for example, x and y. Then what the function does is that it adds these two arguments. For example, these arguments here are x and y, so it will be a x plus y. Then I close it. Now let's create a simple function, and this function I call it multiply underscore 10. So what this function does actually is that it takes a number and it multiplies by 10. As simple as that. So this function takes a number and it multiplies by 10. So I'm calling this function multiply by 10. And then I call I use this function then number is the argument. So I can use here, for example, I may use here x, I may use y, anything. So I'm using here number. So this function of mine, the only argument that I'm specifying here is that number. Then I open the curly braces. So this is the body of the function. So I want it to print the number. Then this is the return value. This is the return value. Now you can explicitly type your return, or R will automatically return it will return what the function does automatically. So if I run this, as you can see, my environment is empty, but if I run, here it is, the name of that function, multiply by 10. Now I want to see if this function of mine works. So yeah, I'm saying the name of my function is multiply by 10, and then I provide the argument. This is the argument here, number. So it takes only one number. So what it does is that it will first of all print the number. What number is that? It will print 5. Then the second thing that it does, it will multiply the number by 10. So there it is. So the return value it has printed 5, then it multiplied by 10. So this is 50. I'm creating another function here, and I'm calling it summation. And this function is just a simple adder. It will take it adds its arguments. So I'm calling this function summation, and I'm calling the I'm using function. Then my arguments are A, B, and C. And then I'm saying print what? Print A, B, C. So I can as well comment here that this is a simple, adder, simple as that. So this one returns the summation of A, B, C. And if I run this, it is the second function of create is called summation. Now I'm saying summation. This is a summation function. So it will sum this is A, this is B, this is C. I can as well change this one to different values. For example, 50, 150, 100. Where run this should be 300. Error in ABC, invalid printing digits. See what might be the problem here. 50. Let's see, 5, 10, 15. So this, and here it is. And here it is the summation of 10 plus 5 plus this is 15. So that is my simple summation function. I'm creating another function here called circum for calculating the circumference of a circle. The circumference of a circle is given by the formula pi. You multiply by the diameter. So I'm calling this function circum for circumference. Then I'm calling the function, and then I'm giving out the arguments, which is d, which is the diameter. When I open the curly braces, I want it to print the diameter first of all, and then it should return pi multiplied by the diameter, whereby pi is a function of instance. Remember, pi. See pi first. Pi is 3.14. Now I run this function. Here it is, circumference. Then I want to find the circumference of a circle whose diameter is 100. And there it is, 3.14. So basically, that's all about functions. Most functions that we will be using have been created, so we won't be creating so many functions. But when need arises, it's good to have the basics for creating your own functions. Thank you. Enjoy learning.